Okay guys, so there is one more section in your electrolysis, that is product of electrolysis or qualitative aspect of electrolysis. Okay, so no need of discussing about the quantity which is deposited in the cathode or anode, simply which species may discharge to the anode or discharge to the cathode. That is the discussion. Okay, no need of considering the amount, simply its nature. Okay, so let's have a look. First of all, I have sodium chloride, NaCl, which is in the fused form or molten state. Fine. So we know that electrolytes can conduct electricity in fused form or aqueous state, right? So now your sodium chloride is in the fused form, so it can conduct electricity. And when it conducts electricity, it becomes Na plus and Cl minus, and we know that they may attract towards the respective electrode, right? Yes. So there is no doubt Na plus may attract to the cathode, since it is cation. How it become, or how will be the reaction? Na plus plus 1 electron gives Na. Na plus plus 1 electron gives Na. What about Cl minus? Cl minus may attract towards the anode, and the reaction is simply Cl minus become Cl2 plus 2 electron. Okay, because we all know that halogens are exist in diatomic form, or this can be written in this form also, a single Cl minus which become half Cl2 by the liberation of 1 electron. Okay, there is no controversy or there is no doubt that Na, sodium, will be deposited on the cathode and chlorine will be liberated on the anode. There is no doubt. But in the case of your aqueous NaCl, what it is? Aqueous NaCl. Aqueous NaCl means there is your sodium, Na plus, Cl minus, as well as water. And you have to know that water have a ready tendency to become, or water have a tendency to oxidize or reduced. Let me discuss about that. So here will be a competition. Before that, let's check how the oxidation and reduction of water takes place. Ready? That is for water, water can oxidize or water can reduce. That based on their difference in or that based on the condition. Okay, and the condition that depends on electrode potential or reduction potential of water. Listen, water which, first of all, let me define the reduction of water. Water, when it absorbs 1 electron, it becomes half H2 plus OH minus. Half H2 plus OH minus. Okay. So it is clear that the species in the water will be in this form, right? H plus and OH minus. So the reduction will be by your H plus. So it becomes half H2. So it is clear that if water reduced, if water accept electron, then the product will be hydrogen. Hydrogen liberated. Tell me, hydrogen liberated at, since it is a reduction, the liberation will be at cathode, right? Yeah. If water reduced, hydrogen will be reduced at hydrogen will be liberated at cathode. Okay, and the corresponding reduction potential, standard reduction potential for the reduction of water is minus 0.83 volt. Similarly, your water can lose electron also. For example, have H2O. When it loses electron, what happens? It becomes 2H plus plus half O2, and the liberated oxygen is from your sorry, liberated electron is from your oxygen. Okay, we know that this water can be written in this form, 2H plus plus O2 minus. So oxygen have excess electron, so it can donate that or can liberate that electron, and that electron will be liberated to the anode. Okay, and it become what? Oxygen. So it is clear that if water oxidized, here the reaction is oxidation because loss of electron, right? So if water is oxidized, what happens? If water is oxidized, then oxygen will be liberated. Since it is oxidation, the liberation will be at the anode. So it is clear that water can oxidize to form oxygen, or water can reduce to form hydrogen. So keep it in mind. This is a very important point. And the standard oxidation potential for this this oxidation is minus 1.23 volt. Ready? Fine. So this idea you have to know. Ready? Now there is a controversy. The controversy is that there is a competition for reduction as well as oxidation. For reduction, the competition is between your Na plus and water. Similarly, for oxidation, the competition is between your Cl minus and water. Are you okay with this? Yeah. We all know that Na plus can reduce and Cl minus can oxidize by looking to the first example, right? And moreover, now we have water also, and it is clear that water can reduce or water can oxidize. That depends on the condition, or that depends on the potential offered by the cell, okay, or offered by the system. So here is a competition, and in this competition, you have to know that water will reduce and Na plus will not reduce. Okay, and that depends on the relative reduction potential. Relative reduction potential. Okay, relative reduction potential. So if water is reduced, what happens? What is the product at a cathode? Since it is reduction, the product will be at cathode, right? So here there is no competition. So Na plus should reduce and it should deposited in your cathode. But here is a competition between your Na plus and H2O, right? So I simply said that in this competition, water will win, so that hydrogen will be liberated at a cathode. Similarly, what about here? There is a competition for oxidation of Cl minus, and we know that Cl minus can oxidize, and competition for the oxidation of Cl minus and oxidation of water. If Cl minus oxidized, chlorine liberated at anode. If water oxidized, oxygen liberated at anode. So here, chlorine may want the match. Okay, so chlorine will be liberated in the anode. So in this competition, chlorine have a dominance. Ready? And I'll give you the necessary explanation for that criteria for choosing a particular species from the two. Ready? Here I simply choose water for reduction, and here I choose what? Chlorine for the reduction. How the prediction can be applied, I'll discuss about it. Okay, so simply you have to know that here chlorine is liberated at the anode. Ready? So this is the most important case. In the case of fused form, there is no competition. Okay, but in the case of aqueous form, there is a competition with the water always. Okay, so first of all, you have to know water can oxidize or water can reduce. Okay, that depends on condition. If water is oxidized, then hydrogen will be deposited or liberated in the cathode. If water is reduced, hydrogen will be liberated in the cathode. or if water oxidized, oxygen will be liberated at the anode. Okay, so if there is a competition, then we should have some ideas to predict which one will dominate, or which one will win the match or win the competition. Okay, fine. So for that, let me show some points. So this is the most important case, and the question may be asked from here. Okay, and I'll give you some supporting points. Then only we can predict which goes to anode and which goes to the cathode. Okay, fine. Listen carefully. The important points are species means ions, or simply something which is ready for deposition or discharge. Okay, species with a greater standard reduction potential. Okay, will be reduced at cathode. A species with a greater standard reduction potential will be reduced at cathode. Greater means more positive. Greater, the sense is more positive. Ready? Fine. Okay. So first of all, my first point, that is Na plus, K plus, then Rb plus, Cs plus, like that. And your second group teams, what are they? Mg2 plus, Ca2 plus, Sr2 plus, and the 13th group, Al3 plus, and Mn2 plus. They all have less standard reduction potential than what? Water. We know the standard reduction potential of water. It is minus 0.83. And these all species have a standard reduction potential which is less than your water. Then what happens? If there is a competition between these species, these ions and water for reduction, then which will be dominator, or which can discharge in the cathode? And that is the first point. What? A species with a greater standard reduction potential. So among these, which have greater standard reduction potential? Water. Okay. So if there is a competition between these all species with your, this is simply first group, second group, and 13th, like that, including manganese also. Fine. Listen. If there is a competition for the reduction with the first group or second group or 13th group cations with your water, then water will win the competition, or water will be reduced, which means hydrogen will be at a anode. Hydrogen discharged at anode. Is it okay for you? Hydrogen discharged at anode. What is the necessary reason? These all have a less standard reduction potential. Less means more negative standard reduction potential than water. And we all know that the standard reduction potential of water is minus 0.83. So these all teams have a value of standard reduction potential which is less than 0.83, minus 0.83. That's why your water discharged. Ready? So moving to the second point. All other, which means all other means other than first, second, 13th. For example, Cu2 plus, Zn2 plus, Ag plus, and your Hg2 plus, like that, etc. Okay, these all have greater standard reduction potential than water. So it means that if there is a competition between these ions with your water, these ions may dominate, or these ions may win the match or win the discharging. Ready? So they will deposit at a cathode. So these species may deposit at a cathode. Ready? Okay. Fine. So that's all about the first point. Second point is something related with this is related with the reduction, right? And the next point is related with the oxidation. So species with a greater standard oxidation potential SOP will be oxidized at anode. Will be oxidized at anode. Okay, that is the first point, or that is the most important point. Let me write two more points in this case. Listen. Cl minus, I minus, Br minus. Okay. Have greater SOP than water. Then what happens? If they all have greater SOP than water, then if there is a competition between these species with water, what happens? These species will be oxidized. They will oxidize. Is it okay? The next point, that is a polyatomic species like PO4 minus, SO4 2 minus, OH minus, NO3 minus, NO2 minus, CO3 2 minus. These all have less SOP, less standard oxidation potential than water, which means that if there is a competition between these ions with water, what happens? Water will win the competition. Okay, so if water wins the competition, means water get oxidized. If water get oxidized, means oxygen discharged at tell me, anode. Okay, there is an exception. Actually, standard oxidation potential of Cl minus, that is less than standard oxidation potential of water. Okay, actually the standard oxidation potential of Cl minus is less than standard oxidation potential of water. Okay, so actually your water have to oxidize in chem. Wait, here is one more. Here is F minus also. If there is a competition between F minus and water, then water will win the competition because water have greater oxidation potential. Like that, Cl minus also, if there is a competition between Cl minus and Cl minus and water, then a greater SOP is for water, but actually the species which oxidized is Cl minus. Okay, so some of you may have a doubt with the last mentioned point. Let me define, or let me introduce that point once again. Okay, put it as a note. Actually, the reduction RED, simply you have to mention H2O bar of H2 OH minus, which represents that H2O become hydrogen and OH minus. And this value we already discussed, it is 0.30 minus 0.83. So compare these two, which have greater reduction potential. So standard reduction potential of copper, Cu2 plus, that is greater than the standard reduction potential of what? Water. So first point is okay. Then what about the second point? The second point is oxidation potential of copper. What do you mean by oxidation potential? The potential involved in the process of oxidation. The process of oxidation of your copper means Cu becomes Cu2 plus. And this value will be exactly the negative of the reduction potential, that is minus 0.34. But the oxidation potential of water is not exactly the negative of this one because the reactions are entirely different. Okay, that is reduction of copper means Cu2 plus 2 electron gives Cu, right? And the oxidation of copper means Cu become Cu2 plus 2 electron. It is clear that these two reactions are inverse. So automatically the potential will be exactly the negative. But in the case of water, we know that the reduction of water is H2O become half H2 and OH minus, but the oxidation of water means H2O become half O2 H plus, half O2 H plus. Ready? So these two reactions are entirely different. Already seen that the oxidation and reduction. Okay, fine. What is the value? Minus 1.23 volt. So tell me whether the oxidation potential of copper or water is greater. Greater means more positive. No doubt, this is greater. So it is clear that standard oxidation potential of Cu, that is greater than standard oxidation potential of water. So this is a concept. Okay. So if there is a competition for reduction between your Cu2 plus and water, then Cu2 plus will reduced because its standard reduction potential is greater than water. And if there is a competition for the oxidation of copper and water, then copper will oxidize because its oxidation potential is much greater than water. Ready? So keep that point in mind. Fine. So that's all about the cases. So let me conclude that you have to know this much, you have to keep this much idea, that is, if there is a competition for reduction between your first group elements, first group cation, second group cation, and Al3 plus, Mn2 plus, like that, then which is in a competition with the water, then water will reduce and cathode have hydrogen. Okay, cathode have hydrogen. Like if there is a competition for reduction between all other cations, all other ions, all other cation, like your Zn2 plus, Pb2 plus, Fe2 plus, Cu2 plus, Ag plus, Hg2 plus, like that, with your water, then water will, they will reduce because their reduction potential is much greater than water. Okay. And the next point, that is, if there is a competition for oxidation between your polyatomic ions and fluoride, F minus, and all other polyatomic ions, SO4 2 minus, NO3 minus, PO4 3 minus, CO3 2 minus, like that, then what happens? Water will oxidize and the product will be oxygen. And if there is a competition for oxidation between your Cl minus, I minus, Br minus with your water, then your Cl minus, Br minus, I minus get oxidized to become chlorine, bromine, iodine in your anode. Okay. And moreover, if there is a competition between reduction and oxidation between water and copper, or water and silver, they get water and silver, then copper or silver will be oxidized as well as reduced. And that is the concept which is just explained before. Okay, fine. So first of all, I'll give you some examples. Let us check what is a product in your anode and cathode. Okay, first of all, the very same aqueous NaCl. Aqueous NaCl means we have Na plus and water for a reduction competition, as well as Cl minus and water for oxidation competition. Okay, tell me, if there is a competition for the reduction between first group elements and water, water will dominate. Na plus won't discharge and water will be discharged in the cathode. Okay. So the product at cathode, water is reduced means at cathode it will be hydrogen. Ready? Okay. And what is in your anode? Cl minus and water. There is an exception. Actually, the standard oxidation potential of water that is greater than Cl minus, but due to our potential, chlorine will be discharged. That is an exception that is already discussed. So at anode, there is a combination between chlorine and water. Chlorine will discharge. At anode, chlorine. Okay. We all know that if water reduced, product hydrogen, right? And ion will be OH minus, which means solution become basic. If water reduced, the solution will be basic. Like if water oxidized, what happens? The product is oxygen. Then what is the ion which is left in the reaction tank or electrolytic tank? It will be H plus, which means the solution may be acidic. Keep it in mind, it's very important. What about this case? Here water reduced, no doubt. But here water reduced, then what happens? There will be an excess OH minus. So the solution basic. Is it okay? Here there is no reaction for water. Fine. The next one, AgBr aqueous. Okay. So there is a competition for reduction between Ag plus, Ag plus and water. Moreover, Br minus and water. What happens? Ag plus with water. Ag plus will discharge. Okay. So silver at cathode and Br minus and water. Bromine get discharged. So bromine at anode. So there is no reaction for your water. So there is, if water is oxidized, H plus, water is reduced, OH minus. If water do not undergoes any reaction, there is no excess H plus or OH minus. So the solution will be neutral itself. Okay, fine. But here water is reduced. That's why there is an excess of OH minus. Then the solution is basic. Okay, fine. Let's have a very important point. Aqueous copper sulfate using inert electrode. Let the electrode is platinum. Using inert electrode, let the electrode is platinum. Okay, fine. Aqueous copper sulfate using platinum electrode. So Cu2 plus water. Moreover, there is a competition between SO2 minus and water. So now you are able to say that which one undergoes discharge or which one will be discharged. Cu2 plus, not this one. So at cathode, copper. In your cathode, it will be copper. And it's a competition between your polyatomic ion SO2 minus with water. Water will be, tell me, water will be oxidized. If water is oxidized, oxygen will be liberated at the anode. If oxygen is liberated at the anode, then there is an excess of H plus concentration. Then this solution will be acidic. Okay, for one more point or one more case in this one. The third example is the electrolysis of aqueous copper sulfate using platinum electrode. Let the electrolysis of aqueous copper sulfate using copper electrode. Copper electrode means there is actually copper atoms, right? Yeah. So the electrodes are made up of copper. So there is copper atoms also. Fine. So what about the reduction competition? Reduction competition is between your Cu2 plus and water. But the oxidation competition is between, normally it is between SO2 minus and water. But one more species is there for oxidation. Which one is that? Here there is an involvement of copper. So oxidation may also take place to the copper. Fine. In this competition, we know that copper will reduce and copper at cathode. What about this one? SO4 2 minus of water get discharged? No doubt water. And water or copper get discharged? Yes. Copper have a greater oxidation potential than water. So this one get oxidized. This one get oxidized means Cu2 plus, how the reaction? Cu become Cu2 plus plus 2 electron. So Cu2 plus in the solution. Okay. So there is some kind of difficulties in your mind. Let me discuss that case. So this is an electrolytic tank. We have copper sulfate. Copper sulfate means Cu2 plus and SO4 2 minus. Well, the two electrodes are coppers. Here the electrolysis is using copper electrodes. This is also copper anode and this is a copper cathode. Okay. So actually the reaction is Cu2 plus get reduced, which means Cu2 plus from the solution get reduced to the cathode copper as Cu2 plus plus 2 electron gives Cu style. Okay. Then what is the oxidation criteria? Oxidation is not for your SO4 2 minus, not for your water, it is for your copper. And that is the point which is mentioned as not in the previous section or just before discussed. Okay. So there is an oxidation of copper. Copper is oxidized to Cu2 plus. From where it oxidized? From the electrode. Here we have copper. So that copper is oxidized to the solution as Cu2 plus. So that this Cu2 plus is discharged to the cathode. So a molecule of or atom of Cu is oxidized to Cu2 plus to the solution. And moreover, the Cu2 plus is reduced to the electrode. This is exactly the principle of electroplating. Electroplating. Is it okay? Fine. Okay. So if it is platinum electrode, there is no problem. If this is platinum, this is platinum. So no problems. There is a competition between Cu2 plus and water and SO2 minus and water. Normal case. But if you have copper electrodes in it, then there is an oxidation chance for your copper also. If there is an oxidation chance for copper with water, copper will oxidize because the reason is discussed. Oxidation potential of copper is greater than what? Water. Is it okay? Fine. So the very same type of problem may be asked here also. If I have AgCl aqueous using platinum electrodes or inert electrodes, no problem. There is a competition between Ag plus and water and Cl minus and water. What happens? Fine. Ag plus, here Cl minus. So silver at cathode, chlorine at anode. But if it is using silver electrode, what about the case? The case is the reduction chances between Ag plus and water, no doubt. But the oxidation, in the oxidation chance, it is between Cl minus, Ag plus, Cl minus, water and Ag. Okay, no doubt. Ag will oxidize. Ag will oxidize means Ag become Ag plus plus 1 electron, and that Ag plus here accept electron 2, so that attracted towards the cathode. Okay, this is a reaction actually. Fine. Have some more examples. Okay. Aqueous K2CO3. Fine. So there is a combination between K plus and water, like Ca3 2 minus and water. Fine. K plus with water. Water oxidize. Water oxidize means hydrogen at anode. Sorry, water reduced hydrogen at anode, and there is an excess of OH minus. Okay, and CO32 minus with water, polyatomic ion with water. Water get reduced. Sorry, water get oxidized. So oxygen at anode. Here hydrogen at cathode. Here oxygen at anode. Then what happens? If his oxygen is at anode, water is oxidized, then there will be H plus. So H plus OH minus. The solution will be neutral. Okay, fine. So this is how we can predict the product in electrolysis. Okay, this information is enough for the prediction of product of electrolysis in your case. Okay, and no need of studying the order of discharge potential or something like that. These points is enough. Okay, one more example. If I have sulfuric acid which is in the form of dilute, sulfuric acid is in the dilute form, then hydrogen will be at anode and oxygen will be at cathode. If it is in a concentrated form, and this is discussed in the chapter number 9, hydrogen, for the preparation of hydrogen peroxide, hydrogen will be at hydrogen at cathode, oxygen at anode, hydrogen at cathode, but in anode it will be a salt of Marshall's acid. It's H2OH2 minus. Persulfate ion will be at anode. See the difference. Sulfuric acid concentrated and diluted. It may ask. Okay. So that's all about the prediction of product of electrolysis. I think it is okay for you. Let me do the problems from your electrolysis. So the section electrolysis is over, which means the theory is over. So moving to the discussion of your electrolysis, okay, which consists of quantitative aspect and as well as qualitative aspect. Let's have a look into that, okay.